The pig thing, I'm glad you brought that up, because that is one thing that I keep hearing out here from folks, that there's an attitude about pigs that they're disgusting, they're just dirty creatures, and they kind of just want them dead.
Recent eradication efforts in Texas uncovered something unexpected in the data. What began as routine monitoring revealed a pattern that doesn't match known behavior. The footage suggests that something within the environment is already influencing hog populations in ways that had not been fully understood before. The footage that changed everything. A routine eradication operation in Blanco County recorded unexpected activity during a standard night survey in Texas. Infrared trail cameras placed across dense brush captured movement patterns that did not match known hog behavior. The footage was initially reviewed as part of a typical control assessment, where wildlife teams track herd size, direction, and response to pressure. Now this is where it becomes important. When researchers analyzed the recordings frame by frame, they noticed that the movement did not follow the patterns usually associated with feral hog groups. Instead of scattered or reactive motion, the disturbance appeared structured and coordinated. That distinction is important. The activity was happening outside the expected response to hunting pressure or environmental change. Further review by teams linked to Texas A&M and regional wildlife programs in 2021 showed that certain movements occurred without direct human interaction in the area. The footage suggested the presence of another influence operating within the same environment, one that was not part of standard eradication models. This shifted the focus away from hog behavior alone and toward a broader ecological interaction. This matters because eradication strategies are built on predictable patterns. When those patterns change, the system used to control populations becomes less reliable. In this case, the footage indicated that something within the environment was already affecting hog activity in ways not previously accounted for. The recordings did not just capture animals, they revealed a gap in understanding how the system was actually functioning on the ground. The invasion that never stopped. Feral hogs in the United States trace back to introductions made during the 1500s, when Spanish explorers released domesticated pigs into regions that are now part of Texas. These animals adapted quickly to open environments and began forming wild populations. Later, additional introductions of Eurasian wild boar during the 1900s for sport hunting increased genetic variation and survival ability. Now this is where it becomes important. When these two populations mixed, they created a hybrid species with higher intelligence, stronger physical resilience, and faster reproduction cycles. That distinction is important. Unlike controlled livestock, these animals operate independently and adapt rapidly to threats, making long-term population control difficult. By 2020, estimates place the total number of feral hogs in the United States at around 6.9 million, with over 2.6 million concentrated in Texas alone. This scale is not static. Populations can double within a short period due to high reproduction rates and lack of natural predators in many regions. This matters because the spread of feral hogs is not a contained issue. It is an expanding system that affects agriculture, land stability, and infrastructure. Areas across the southern United States continue to experience damage linked to rooting behavior and resource competition. The invasion did not occur suddenly. It developed over centuries, gradually building into a population level that now exceeds the capacity of traditional control methods. The animal that can't be controlled. Feral hog populations grow at a rate that is difficult to manage under normal conditions. In parts of Texas, studies conducted around 2020 showed that a single group can produce up to 2 litters per year, with as many as 12 piglets in each cycle. This rapid reproduction allows populations to recover quickly even after large-scale removal efforts. Their growth is not linear. It compounds over time, creating pressure that increases faster than control methods can respond. Now this is where it becomes important. When a species reproduces at this scale, traditional control strategies lose effectiveness. That distinction is important. Even consistent hunting or trapping does not reduce the population long-term if reproduction continues at the same pace. In addition to reproduction, feral hogs have strong physical capabilities. They can run at speeds close to 30 miles per hour, break through fencing, and travel long distances in search of food and water. Their thick skin and cartilage layer around the shoulders provide natural protection, making them less vulnerable to light weapons. This combination of speed, strength, and protection allows them to operate in environments where other animals would struggle. Over time, these animals also adapt to pressure. They change movement patterns, avoid traps, and shift feeding behavior based on human activity. This adaptability means that control systems must constantly adjust while the animals continue to evolve their response. The result is a population that does not remain static but actively learns from the environment around it. The damage no one can stop. The impact of feral hogs extends beyond population size and into direct economic and environmental damage. In Texas, annual losses linked to hog activity have been estimated at over $500 million, with national damage exceeding $3 billion each year. These figures include crop destruction, infrastructure repair, and long-term land degradation. Now, this is where it becomes important. The damage is not limited to isolated incidents. It occurs repeatedly across large areas, affecting both rural and developed regions. That distinction is important. The scale of impact means that even small populations can cause widespread disruption over time. Feral hogs damage crops by rooting through soil, destroying irrigation systems, and removing planted areas overnight. In agricultural zones near Dallas, farmers have reported entire fields being lost within a single season. Beyond farmland, the animals have also been recorded near airports, suburban areas, and transport routes, creating additional risks to infrastructure and safety. In some cases, encounters between humans and hogs have led to injury and fatal outcomes. By 2019, documented incidents confirm that these interactions, while rare, are serious enough to be recorded as part of the overall impact. The damage caused by feral hogs is not limited to land use. It extends into safety, economics, and long-term environmental stability across the regions where they continue to expand. The war that failed. Efforts to control feral hog populations expanded across Texas, especially after coordinated programs increased around 2010. Methods included trapping systems, ground hunting, and relocation attempts, all designed to reduce numbers across affected regions. Helicopter operations were later introduced to increase scale, allowing teams to cover large areas quickly. These approaches showed short-term success in reducing visible populations, particularly in areas where access was limited or terrain made ground control difficult. Now, this is where it becomes important. Removing animals in large numbers does not guarantee long-term control when the system itself remains unchanged. That distinction is important. Feral hogs respond quickly to pressure, adjusting their movement patterns and avoiding areas where human activity increases. Over time, repeated exposure to control methods leads to behavioral shifts, making populations harder to locate and manage. Field reports from regions near San Antonio showed that hog groups began shifting activity to nighttime or moving into denser cover after repeated exposure to hunting. By 2018, data suggested that removal efforts often caused groups to scatter rather than collapse. Smaller groups spread into new areas, increasing the overall range instead of reducing it. This expansion created new problem zones, often in areas that had not previously experienced significant hog activity. This matters because each control attempt resets the cycle rather than ending it. Populations rebuild through rapid reproduction, and the system returns to its previous state within a short period. As efforts intensified, costs increased, but long-term results remained limited. In some regions, repeated interventions led to diminishing returns, where more effort produced smaller reductions. This pattern shows that without addressing the underlying population dynamics, control methods remain temporary rather than permanent solutions. The hidden pattern in the brush. Around 2014, researchers in Texas began noticing unusual patterns in areas known for high hog activity. Field teams reported empty nests where piglets should have been present, even in locations without recent hunting or trapping. These findings were initially treated as isolated incidents, but over time, similar reports began to appear across multiple regions. By the mid-decade, the frequency of these observations increased enough to suggest a consistent pattern rather than random loss. Now, this is where it becomes important. When repeated outcomes occur without clear human involvement, it points to another factor within the environment influencing results. That distinction is important. The disappearance of piglets did not match the behavior of known predators in the area, and the absence of clear signs such as scattered remains or prolonged struggle made the events difficult to classify using existing models. Detailed examination of sites near Blanco County revealed signs of disturbance that appeared controlled rather than chaotic. Tracks found in these areas did not align with common predators like coyotes or bobcats. By 2016, researchers began documenting repeated cases where entire nests were cleared in a short time frame, often leaving minimal physical evidence behind. This pattern suggested a level of efficiency that had not been previously associated with typical predator behavior in these environments. This matters because it indicates the presence of a system operating outside established control methods. The pattern suggests targeted activity focused on young hogs, affecting population growth at an early stage. Over time, these repeated removals began to influence local population dynamics, even before the behavior was fully understood or formally documented. The footage no one expected. Infrared footage collected during field monitoring in Blanco County revealed behavior that had not been formally documented before. Cameras placed across active zones in Texas during 2021 recorded coyotes moving in patterns that did not match standard scavenging activity. Instead of wandering or reacting to opportunity, the animals appeared to follow structured movement, entering and exiting areas with timing that suggested coordination rather than chance. These recordings were captured over multiple nights, across different locations, showing consistency rather than a single unusual event. Now, this is where it becomes important. Predator behavior is usually opportunistic, especially in mixed environments where food sources vary. That distinction is important. What appeared in the footage was not random hunting. It showed defined roles within the group. One animal would move forward to draw attention, while others positioned themselves along the sides, controlling movement paths within the brush. Satan reduced the ability of piglets to escape and limited the reaction time of adult hogs. Further analysis conducted by wildlife teams linked to Texas A&M showed that these movements were repeated across multiple recordings. In several instances, activity lasted only a few seconds, with piglets removed before adult hogs could respond. The precision of these interactions suggested that the animals were not learning individually, but operating within a shared pattern of behavior. By 2022, additional reviews confirmed that this was not limited to one group, but appeared across different areas with similar environmental conditions. This matters because it introduces a level of organization not typically associated with small predator groups in this region. The footage does not show isolated success. It shows a consistent method being applied across different locations, indicating that this form of predation is more widespread than previously understood. It also suggests that these patterns may have been present for years but remained unnoticed due to the lack of continuous monitoring systems, the strategy that breaks the system. The observed behavior focused on a specific target within hog populations. Coyotes avoided direct engagement with adult hogs, which are large, aggressive, and capable of defending themselves effectively. Instead, the activity captured in areas near San Antonio showed repeated targeting of piglets, particularly in nests identified during field checks in 2016 and later. Now, this is where it becomes important. Population control does not depend only on reducing numbers in the present, it depends on limiting future growth. That distinction is important. By removing piglets before they reach maturity, the impact extends beyond immediate loss and affects the next reproductive cycle. Field observations showed that piglet removal occurred before groups could expand, interrupting the rate at which populations typically recover. In some monitored zones, early-stage losses reduced expected growth patterns, altering the timeline of population increase. This approach does not require large-scale removal. It focuses on timing and vulnerability within the life cycle. This matters because most human control methods target visible populations rather than future reproduction. The behavior recorded in these areas reflects a different approach, one that affects the system at an earlier stage. By focusing on younger animals, the impact extends forward, reducing the number of individuals that would later contribute to population growth. The discovery that changes everything. Field studies began to show a measurable pattern in areas with high predator activity. Analysis conducted across parts of Texas during 2020 found that piglet remains appeared in close to 30% samples collected from coyote populations. This was not an isolated observation, but a repeated result across multiple study zones, suggesting consistent interaction between species rather than occasional behavior. Over time, similar findings were reported in separate locations, strengthening the reliability of the data and confirming that this pattern was part of a broader ecological process rather than a localized anomaly. Now, this is where it becomes important. Population control is not only about removing large animals, but about limiting future growth cycles. That distinction is important. When early-stage individuals are removed before maturity, the impact extends forward into the next generation, reducing the number of animals that can reproduce and sustain the population over time. This shifts the focus from short-term reduction to long-term structural change within the population. In monitored regions near hill country, researchers observed that hog populations declined by nearly 20% drop without direct human intervention. This reduction was linked to sustained predation on piglets rather than adult animals. In areas with higher coyote density, estimates suggested that more than 30% loss of piglets occurred before they could contribute to population growth. These effects were not immediate, but became more visible over multiple breeding cycles, showing a gradual but consistent impact. This matters because the effect builds over time. Instead of reducing visible numbers temporarily, this pattern alters reproduction rates at the source. As fewer piglets survive to maturity, population recovery slows down, and growth curves begin to flatten. In some regions, this has led to stabilization without the need for continuous intervention, showing that natural systems can regulate population dynamics when key interactions remain intact. The disturbing truth behind the footage. For many years, predator control programs focused on reducing coyote populations across Texas, particularly between 1990 and 2010, when bounty systems were widely used. These programs paid hunters to remove coyotes in large numbers, with the goal of protecting livestock and stabilizing rural areas. The approach was based on the assumption that fewer predators would reduce overall risk to agriculture. Now, this is where it becomes important. Removing one part of an ecosystem often shifts pressure elsewhere rather than eliminating it. That distinction is important. As coyote numbers dropped, the natural control on feral hog populations weakened without being replaced by another system. In several documented areas, including regions near West Texas, coyote populations declined by more than 60% reduction over time. Following this decline, hog populations expanded rapidly, with some areas reporting a 3 times increase within a few years. This change did not occur randomly. It followed the removal of a natural balancing factor within the environment. This matters because it shows how control strategies can produce unintended outcomes when systems are treated in isolation. The footage did not introduce a new threat. It revealed an existing relationship that had been overlooked, where predator activity played a direct role in limiting hog population growth before human intervention altered that balance. The findings from these observations are changing how the situation is understood. What appeared to be a problem driven entirely by human control methods is now being viewed within a larger system. The behavior captured in the field shows that population changes are not always the result of direct intervention. As more data is reviewed, patterns continue to point toward natural interactions playing a larger role than previously recognized. This matters because it shifts attention from surface-level control to underlying processes that influence long-term outcomes. When those processes are overlooked, efforts can become less effective over time. At the same time, the balance within these environments remains sensitive. Changes to one part of the system can create unintended effects elsewhere. The relationship between predator and prey, once disrupted, does not immediately return to its previous state. What is becoming clear is that the situation is not defined by a single factor. It is shaped by multiple interactions happening at the same time, many of which are only now being fully understood.